Welcome back. In this lecture, we'll discuss the different options available for assigning values to an array. As always, we'll start by defining an array variable and displaying it. To be consistent, we'll once again call it array A and have it hold the numbers from 1 through 6 divided into 2 rows. Right. To begin with, we can alter individual elements within an array. For example, let's take the third individual element of the first row and set it equal to a different number, say 9. We do this by setting array A, bracket 0, comma, 2, bracket, equal to 9. If we display the array variable right after, we'll see a new 2D array, which looks almost identical to the previous one, with one small exception. The last element of the first row has changed from 3 to 9. Apart from altering individual elements, we can also change entire vectors within an array. These could be either rows or columns, and we'll look at how to assign values for both. Let's take the first row of the array and set it equal to 9 again. We simply write array A and add 0 in the square brackets. When we display the entire Indy array, we see that its entire first row consists of 9s now. Similarly, we can also change all the values from a given column to be 9s by adding a colon and a comma before the index value within the brackets. Splendid work! So far, we've examined how to assign identical values to each position within an array. But what if we wanted to assign different ones? Well, we can do so with the help of a list. Start off by defining a list containing 3 numeric values. In case anybody needs a refresher, it's the same as defining a one-dimensional array without using the NumPy function. So we write list A equals, and then we place the 3 values within square brackets. Next up, using the index notation we covered earlier, we set the first row of array A equal to our newly created list. Thus, if we call array A on the next line, we'll see that it now has the values of list A as its first row. However, is the first row of the array now a list, or is it still an array as well? Instead of speculating, we can call the type function and see that it is indeed an Indy array. Nice! Therefore, it is important to note that even if we set a specific part of an array, like a row or a column, equal to a scalar or a list, the array simply takes the values rather than the type. A third option is to change the entire array to consist only of a single value, like 9. We can do so by writing a single colon instead of any indices within the square brackets. This notation tells Python to go through all the rows and assign to each one the same value, which is 9 in our case. If we once again display array A afterwards, we'll see an array full of only 9s, which is what we expected. But wait, if we're making all the values of the array the same, can't we just set the entire array equal to the number 9? Well, let's do that and see what happens. When we display the variable, we now see an integer rather than a 2D array. Hence, it looks like we've overwritten the array completely and have saved a number in its place. We can check if that's the case by calling the type function. The output states that array A is now an integer, which means we no longer have our original 2D array. Since we want to keep assigning values to an array, we'll need to redefine array A. For simplicity, we can just copy and paste the code from the beginning of the video. All right. Now that you know how to assign values to arrays, it's time we discussed one of the most important features of Indy arrays, element-wise properties. In the next lecture, we'll explain them and how they work. Thanks for watching.